Hi, welcome to Raw Math. Today I'm doing a series of videos on exponents, and what this video is just going to cover is how to raise a number to an exponent and determine if your answer is positive or negative. Now remember, an exponent is a counter counting how many times a base is multiplied to itself. So if I have 7 cubed, this is really the same as 7 times 7 times 7, which is 343. Negative 6 cubed is the same thing, except that each of the numbers that are being multiplied are negative. So I have negative 6 times negative 6 times negative 6. Well, 6 times 6 times 6 is 216. A negative times a negative is positive, so those negatives cancel. We have one negative left over, so it's going to be negative 216. The rule, because I'm not going to write any more of these out before getting to the number, is if your exponent is even, 2, 4, 6, 8, 10, your answer is positive, because a negative times a negative is always positive, and if you have an even number, they can always pair off, and every pair becomes positive, positive, positive. So they all pair off, they all become positive, your answer is positive. If you have an odd exponent, they'll pair off, but the last one will define your sign. So the odd thing about an odd exponent is if your base is positive, your answer is positive. If your base was negative, your answer is negative. The odd thing about an odd exponent, it doesn't affect the answer. Okay, so 10 to the fourth, 10 to any exponent, the number tells you how many zeros. So 10 to the fourth is 1 with 4 zeros. Negative 10 to the fifth. Now here is a trick. This is really negative 1 times 10 to the fifth. That negative 1, that 5 only is on the 10, not on the negative 1. So the negative 1 isn't being multiplied out 5 times. There's just a single negative. And a negative 1 times anything, the answer will be negative. So we have 10 to the fifth, which is a 1 with 5 zeros. But that negative 1 isn't being taken to the fifth, so your answer is negative because there's nothing to affect the negative. There's no exponent. On the next one, again, we have a negative 10 to the fifth, but this time the negative 1 is being taken along. It's like this problem here, where it's negative 10 to the fifth. But like I said before, these two pair off, making a positive. These two pair off, making a positive. And that fifth one means that that power to 5 is going to remain negative. So we have a negative 1 with 5 zeros. For the next one, negative 10 to the fourth, the first two pair off, the second two pair off, everything pairs off. Negative times a negative is positive. It means our answer is going to be positive. Even exponent, positive result. Odd exponent, the result is the same as the original base. Okay, 1 with 4 zeros. So here we have, and this is kind of tricky, we have a negative and we have a negative. Well, negative 4 cubed, because this is odd, the sign is the same as the base. So that's going to be negative 64. But that negative isn't touched by the cube. The cube is only touching what's in the parentheses, so that negative stays out front. Well, minus a negative is plus a positive, so this becomes a positive 64. Similar with the next one. The negative 15 squared, because it's even, the negative 15 squared is positive, but that negative isn't being touched. So we have negative times 225, or a negative 225. On this last one, the only thing you need to remember is that this exponent is multiplying both top and bottom. It's 4 fifths times 4 fifths times 4 fifths times 4 fifths. And because it's the full fraction being multiplied 4 times, you really have 4 to the fourth, which is 256, over 5 to the fourth, which is 625. It's not reducible. It would be reducible here. Because this is an even exponent, your answer is positive, so we don't have to worry about the negative. When I do these problems, I often figure out the number first and then figure out the sign second using the rules so that the negatives don't get in the way of my computation. Okay, I hope you've enjoyed the video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks!